in today's lecture we are going to learn some more concepts of ellipse. So, today's lecture is ellipse number 2. Okay. So, in last lecture we have learned the basic concepts of ellipse, basic ideas, general equation, and now we will move on from there. Okay. We also solved some problems. Today also we will solve some more problems regarding the same. Okay. Okay. So, yesterday we in the last lecture we solved this problem. We also solved this problem and this problem also. Okay. But this problem also we have solved. Okay. Yeah. Now, this problem while solving we could not finish this due to time constraint. So, let us try to finish this problem with a rough idea. Okay. Because I skipped it thinking that students will complete it, but due to time constraint, but it is better that I give an idea of how to do that at least in a rough manner. Okay. So, basically we got something like x minus 1 whole square divided by 25 plus y minus 2 whole square divided by 9 equal to 1. We got equation like this. Now, how do we proceed? What is A, what is B? Whatever is the bigger in these denominators will become A. Okay. So, that means that becomes the major axis, whatever is lower will become the minor axis. So, I can take 5 as the semi-major axis, 3 as the semi-minor axis. Now, this is a shifted ellipse. So, if we understand this geometrically, okay, so let us say I have taken this to the next page and let us say there is an ellipse like this. Okay. So, let us say there is an ellipse and we have this major axis. Okay. Because here the highest value is below x term only. So, that means major axis is parallel to x axis. Okay. So, here major axis is parallel to x axis, this is our x axis. Okay. So, let me draw this x axis again. Okay. And our minor axis is parallel to y axis. So, let us say x and y axis are somewhere like this. Okay. So, this is like a reference system, it need not be an accurate system. Okay. And we know the center. The center point is where both these terms become zeros. Okay. So, x equal to 1, y equal to 2 is where these two terms both become 0. So, the center point is basically 1, 2. Now, from this point we have to move how many units right side to get focus? We have to move a into e. Okay. So, this distance is basically a into e and it is going to be parallel to x axis. So, on this line y must be equal to 2, that is fixed, and on this line x must be equal to 1. Okay. So, let us evaluate what is AE and what is A by E. Okay. So, E that we have to calculate here. So, E is going to be root of 1 minus B square by A square, which is going to be root of 1 minus 9 by 25, which is same as 4 by 5. So, A into E is going to be 4 and B is already 3. Okay. So, using these let us design and also we need A by E. So, A by E becomes 5 by 4 by 5, which will basically be 25 by 4. Okay. So, then what happens to all this? So, this point should come 4 units away from this, but we are moving parallel to x axis. So, only x coordinate will change, y will not change. So, it becomes 5, 2. What about this vertex? So, we are moving 5 units away from the center. So, it becomes 6, 2. Now, similarly, if we go in the negative direction, we should get the other points. So, the next focus, this is our S, this is our S dash. So, S dash is going to be, from this we have to subtract 4 units from x coordinate. So, that means it becomes minus 3, 2. And this point it becomes minus 4, 2. Okay. So, we got all vertices, we got all foci, we got the center also. Now ends of minor axis we can calculate, okay, because we have to go 3 units up because B is 3 units. So 3 units up means here y coordinate changes but x will not change. So it becomes 1 comma 5 and this becomes 1 comma, from 2 we have to subtract 3, 1 comma minus 1. So these are the main points. Now what else do we have to calculate? See, we calculated vertices, foci, we need directrix. Now directrix is basically somewhere here. Now this is A by E units away from this center. So to the x coordinate we have to add A by E to get the foot of the directrix. So this point will become 1 plus A by E. What is A by E? 25 by 4. So 1 plus 25 by 4 will become 29 by 4 comma 2. Similarly this foot of the directrix. So this will become 1 minus 25 by 4. So that will become minus 21 by 4 comma 2, that will be this point. So equation of this directrix will be x equal to minus 21 by 4. Equation of this directrix is x equal to 29 by 4. So we got directrices also. So this is also tick mark. Now latus rectum. How do we find latus rectum? Whenever in any question, if only latus rectum is mentioned, so it is basically 2b square by a, so which becomes 2 into 9 by 5, which is 18 by 5. Okay, so latus rectum means we only have to find the length, but here we can also find the points which are the ends of latus rectum. So we can also find the ends of latus rectum. We know that the total length has to be 2b square by a, which is 18 by 5, half of it is 9 by 5. So by taking the same x coordinate, if I just add 9 by 5 to this 2, I will get one end, and by taking the same x coordinate, if I subtract 9 by 5, I will get the next y coordinate. Okay. So this way we can also find the ends of the other latus rectum also. Okay. So here what you have to observe is how we are generalizing the structure of the ellipse. Okay. So we don't have to learn formulae by heart about every ellipse, even if it is a tilted one, then also we can use the same idea and get it. Okay. So I hope you liked this idea. Take a snapshot of this and then we will move on. Okay. So can we move on now? So next concept is the auxiliary circle. So what is auxiliary circle? So here there must be an I, spelling mistake. So auxiliary circle, it is auxiliary circle. Okay. So auxiliary circle also sometimes called as eccentric circle or eccentric circle. Okay. Eccentric circle or auxiliary circle, both are same. Okay. Now the circle described on major axis as diameter is called as the auxiliary circle. Now this is true for hyperbola also. So one of the axis is major, one of the axis is minor. Major means of the prominent importance, the axis on which foci and directrices, foci and vertices lie, that axis is called as the main axis. So by taking that main axis as the diameter, if we construct a circle, it becomes auxiliary circle for ellipse and also for hyperbola. So here if we take this ellipse, by taking these vertices as the ends of diameter, if I draw a circle, it becomes the auxiliary circle. So here if we take the equation of ellipse as x square by a square plus y square by b square equal to 1. So a comma 0 and minus a comma 0 are these points which are diametrically opposite. So that means our length of the radius will become a units only. By taking a units as the radius, if we draw a circle, it becomes the auxiliary circle. Now for the other ellipse where a is less than b, then b is basically the semi-major axis. In that case, by following the same logic, we can also understand that x square plus y square equal to b square will be the auxiliary circle. But you do not have to learn this by heart for every different case. No, just like the way I have solved here, we only have to remember the idea. Okay, later on shifting the coordinates and all, it becomes very easy if you remember the logic. Okay. So, my idea is very simple. I try to spend less and less time and efforts on remembering. Okay, don't waste your bits and bytes of your memory on remembering things like this. Go for one generalized form and then keep applying it for everything. Okay. Okay. So, this is the concept of auxiliary circle. Okay. Now, what is the importance of this auxiliary circle? That we will see in the next page. That is here. Okay. Which is the parametric form. We will come to that before after we do this notation. Suppose let us say here it must be minus sign. Okay. Suppose let us say we have taken this expression x square by a square plus y square by b square minus 1. We generally name it as S. Okay. S stands for curve. S equal to 0 means it is the equation of the curve. And S11 will become the complete substitution. This is actually minus sign. Okay. It is a minus sign. S11 means complete substitution. S1 means partial substitution. So, when it is squared, we have to give only one x. X square is x into x. We have to give only one to the point and other must be variable. Okay. And S12 means it is partial substitution of 1 and 2. Okay. So, this is standard notation. S11 and S12, these two are constants because we have substituted the points completely. There are no variables involved. So, these are constants, these are numbers. Okay. But this S1 is of the degree 1. So, when I equate S1 to 0, S1 equal to 0 is going to give me a straight line. Now, what is going to be this straight line, that we do not know, that we will evaluate when we go for tangents, chords and normals. But until then, remember that it is a line. Now, S equal to 0 represents a curve and it is true for all general curves of second degree. Okay. Now, if the point is inside the ellipse, whether it is here or here or here, anywhere, S11 has to be less than 0. Okay. So, if S11 is less than 0, then that means point lies inside the ellipse. Now, if 11 is greater than 0, point is outside the ellipse. If 11 is equal to 0, point is on the ellipse. We already know this notation. Okay. This is the basic notation. Now, let us look at that parametric form. Okay. Now, to understand this parametric form, first you need to understand the algebraic point of view. Okay. For example, here if we put x equal to a cos theta, y equal to a sin theta, b sin theta, then a square and b square will get cancelled and that will satisfy the equation. So, algebraically we can say that this form is basically a form where we are directly connecting x and y using a independent parameter which is third parameter which is theta. So, we have broken the entire equation from one single form to two different forms. It is called as parametric form. Okay. So, here we remove the dependency of y on x, we put both x and y as dependent on theta. This is one way. This is the algebraic understanding. So, this means we can also get more and more algebraic parametric forms. For example, let us say I take x equal to a into t by root of 1 plus t square and y equal to b by root of 1 plus t square. Suppose let us say I take one algebraic parametric form like this. Now, will this equation be satisfied with this form? Will this equation be satisfied? Of course, it will be satisfied. You just put it and substitute and see, of course, it is going to satisfy. But can we call this as the parametric form of ellipse, which is the standard parametric form? No, we can't. So, this way algebraically there can be many such forms where we are introducing third parameters. Here my parameter is t, okay. So, this way we can introduce many parameters, but the theta parametric form has a significance that we can understand from this eccentric circle or auxiliary circle. Suppose let us say I take any point here P, let us say my point P is somewhere here, okay. Now, if I draw an ordinate, what is the meaning of ordinate? Perpendicular drawn to x axis, and if I extend this, so here this ordinate is going to cut the auxiliary circle at some point. If I take this point as let us say P dash, then if I join this center, let us name it as O and P dash, then because P dash is moving on circle of radius, what is the radius? A units, I can take this point P dash as A cos theta comma A sin theta. Here what is the theta? Theta is basically this angle, okay. Now, theta is the angle formed by P dash which is on the auxiliary circle or eccentric circle. Now, if I join O and P, now what happens? If I join O and P, what happens? This P, OP vector can also be written as OP dash vector, but before that let me just explain you one more idea. P and P dash are vertically on the same line. That means they should be having the same x coordinate. So, x coordinate of P must also be A cos theta. Now, can we put A cos theta in this equation and find y coordinate? Of course, we can. So, A square cos square theta by A square plus y square by B square is equal to 1. So, here A square got cancelled. When I take the cos square to the other side, I am getting 1 minus cos square theta which is same as sin square theta. So, this is actually giving me y equal to B sin theta. So, which means the y coordinate of this P point must be B sin theta. Now, why did I take it as positive? Because it is in the above x axis region. So, y must be positive. If I had taken P in the below x axis region, I must have taken it as negative. That is fine, that is the sign convention. But here you observe that P has A cos theta B sin theta as the parametric coordinates, and here theta is not the angle made by P, it is the angle made by P dash with x axis. So, because the point on the eccentric circle is making the angle, we name it as eccentric angle, okay. Because the point on eccentric circle is making the angle theta, we name it as eccentric angle. There is a reason why we named it as eccentric angle, okay. Now, here there is also a standard property that you can observe, okay. So, on this ordinate, so if we take this point as let us say N, so there are 3 points here, one is P dash, one is P, one is N. Now, these 3 are always in the same ratio. P divides P dash and N every time in the same ratio. It is a standard property of the eccentric circle, okay. So, we can also say that locus of a point P dash, which divides P and N, Pn line segment in a particular ratio externally is an eccentric circle. We can also define eccentric circle or auxiliary circle this way, okay, because this ratio is always constant. You can also verify it here, because if I try to find the coordinates of N, they are basically A cos theta comma 0, okay. So, what is the distance of Pn? Distance of Pn is this distance is basically B sin theta, okay. And what about this P dash distance? It is A sin theta minus B sin theta. Now, if you take the ratio of these two, what is the ratio in which they are dividing? The ratio is A minus B is to B. So, this is particularly constant for any ellipse, okay. So, this way we can also understand this property of eccentric circle. This is one of the standard properties of eccentric circle, and you can also learn them here. You can also prove them on your own. Okay. Now, no matter where I take, even if I take one ordinate here, and if I take my point Q here and Q dash here, and if this point is, let us say, M, then MQ and MQ dash, these are in the same ratio as this. Okay. So, you can also verify it will be exactly same ratio. Okay. So, this way we can understand the meaning of the parametric form of ellipse using this idea. Okay. So, if you can take some time to quickly note this down, we will move on to the next idea. Okay, so can we move on? So, here we have basically understood what is the parametric equation, what is the parametric form, and why is it, why is this theta called as the eccentric angle, and what is the meaning of it, why is it named, what is the terminology, what is the property. Okay. Now, if you want to directly connect the angle between the P, angle made by the P and P dash, we can also get one direct property. Okay. So, that we can also observe here, because this diagram is already power packed. Let us go for a different diagram. Okay. So, let us say we have one ellipse here. Let us say we have one ellipse here, and we have one circle here. Okay. And let us say there is a point here P, this is the perpendicular, and there is point here P dash. We are joining this angle is theta, and we join these two. If this angle is, let us say, alpha, okay, and if this point is, let us say, N, and this point is O, so we know that Pn is basically B sin theta. Okay. What is On? On is basically this distance. It is A cos theta. It is same for all of them. Okay. So, On is A cos theta. Okay. Now, if this angle is alpha, so I can say that tan alpha is going to be B sin theta by A cos theta. So, which will give us tan alpha equal to B by A into tan theta. Okay. So, remember that if you are interested in the angle made by the OP vector with positive real axis, positive x axis, okay, then you can use this tan alpha formula to get the alpha. But theta angle is not made by P with x axis, it is made by the P dash with x axis. Okay. Now, as I vary theta, I keep getting all points. Okay. So, when theta is equal to 0, I am on this vertex. When theta is equal to pi by 2, which is 90 degrees, then we are at the ends of one of the ends of minor axis. When theta is 180 degrees, we are at the other end of the major axis. When theta is 270 or minus 90 degrees, then we are at the other end of the minor axis. Okay. Now, when we observe theta and alpha are equal only for 4 locations. Which are these? 0, pi by 2, pi, 3 pi by 2. Only for 4 locations, theta and alpha are equal. For all other locations, theta and alpha are not equal. Okay. And also we can observe that here alpha is actually less than theta. But in this quadrant you can also observe that alpha is going to be, of course, greater than theta. Okay. So, for example, here if you observe, and this angle has to be alpha, and if we join this vector, this angle has to be theta. So, which is bigger? Alpha is bigger. Okay. So, this way you can analyze based on the quadrant, and that is left to you. The more you want to explore, the more you will learn. Of course, you can explore at home. Okay. So, quickly take a snapshot of this also, we will move on. Okay. So, next concept, geometrical interpretation, that is exactly what is put here, presented here, which we had discussed till now. Okay. So, the ordinate of point P on the ellipse meets the auxiliary circle on the same side of major axis. Okay, that is right. And then P and P dash are the corresponding points. Okay. So, P dash point is this and it must be a sin theta. Okay. So, here angle P dash CA. So, here you can observe P dash CA, that means it is an angle made by P dash with positive x axis is basically theta. It is called as the eccentric angle. What is the reason? It is made by the eccentric point on the eccentric circle. Okay. So, it is the basic idea of the parametric form in a geometric representation. And remember that P divides P dash and this point N in the same ratio for every location. Okay. Next. Now, based on this knowledge, let us try to solve some problems. Okay. Now, before we go for the problems, let me also explain one more concept here. Okay. We can also name this as perpendicular form. So, if you remember the normal ellipse, with this equation x square by a square plus y square by b square equal to 1. See, I am following one standard notation that whatever is the bigger is the major axis. Okay. So, here let us say this is my x axis, this is my y axis, and I have taken a point P on this ellipse. Now, distance of P from x axis, is y and distance of P from y axis is x. Okay. Now, I can also name this distance as, let us say, d2 and take this distance as d1. Okay. See, remember, I am taking d1 as the distance from y, d2 as distance from x. Now, d1 square by one constant a square plus d2 square by another constant b square equal to 1. If I get any relation like this, it is going to give me an ellipse. Remember, a and b must be not equal. Okay. Now, that is the basic idea that I have generated from here, but remember that these two lines must be at right angles. Only then we can use this formula to use this form. It is not a formula, it is a form. So, we use this form to derive and solve some questions only if it is satisfied. Now, the other way is this. What happens if A is equal to B? And if these two lines are perpendicular, A equal to B will give us circle. You take this as simple idea that if L1 and L2 are perpendicular lines. Okay, so this is just one simple idea. We are, I think, running out of space here. I will write it here. I will just remove this and I will write. Suppose let us say there are two perpendicular lines. Okay, this is L1 equal to 0, this is L2 equal to 0. And there is one point P which is moving such that this distance is, let us say, d1 or this distance is d2, anything. Okay. So, if I get something like d1 square plus d2 square is equal to constant, it is going to give me a circle. Okay. So, here these two lines must be perpendicular, or in a way we can also say that L1 square plus L2 square is equal to constant will give us circle if L1 and L2 are perpendicular. Okay. Now, coming to this idea. So, using this idea we can also generalize it just like the way we have generalized it for circle for ellipse. Okay. So, suppose let us say we have one ellipse like this, okay, and we have two perpendicular lines like this. So, for any point P whose distance from this line is, let us say, d2, distance from this line is d1. So, if we have a condition like this, d1 square by k1, d2 square by k2 equal to some other constant k3 or 1, it does not matter, okay. Then it is going to represent ellipse provided these conditions are satisfied. K1 into K3 must be positive, okay. So, let us name this right hand side constant as 1 only, so that there is no confusion, okay. This K3 also I should remove. Okay, so K1 greater than 0, K2 greater than 0 and K1 and K2 are not equal. So, by applying this idea also we can get equation of ellipse, okay. So, we can use these ideas in problem solving at later stages. So, this form is called as perpendicular form because we are defining the ellipse using two perpendicular lines. So, we call it as perpendicular form, okay. So, here we have understood what is an ellipse and what are different forms, okay. So, we understood parametric form, we also understood the other form which is the perpendicular form, okay. Now, quickly take a snapshot of this or make a note, we will move on to the problem solving. Okay, so can we move on now? So, there is one problem here. Now, these problems are basically mixture of all fundamentals that you have learnt till now. Now, some of the ideas may repeat. So, if there is any repeating idea, I will just move on, okay. So, a man running on a race course notes that sum of the distance of two flag posts from him is always 10 meters. So, let us say there are two flag posts here and man is running around a track, okay. So, in general mostly the running race happens around either track or on road, which is cross country race. So, here let us not take marathons and all. So, let us take simple running in a basic circuit, okay. We call it as running circuit or track, running track, okay. So, most of the running tracks that you see anywhere either in Olympics or even in your school grounds are not circular, they are mostly elliptical. They should be, but they are not exactly elliptical also. In fact, in schools they follow this kind of system, okay. So, first they make two straight lines and here they will connect them with circular arcs, they do it like this. In most of the schools this is what it is, but imagine that it is an elliptical circuit, okay. So, there is an elliptical circuit and there are two flag posts here and the person is running here, okay. So, person is running here, okay. Now, if it is pointed in this direction, so person is running in this direction, okay. So, he is observing these two pole posts, flag posts from him to be always at 10 meters, okay. So, sum of the distances. So, that means if we name this as point as P and these two as A and B, so PA plus PB is always given as 10 units and distance between flag posts is 8 meters. This is 8 meters. Now, is this sum of distances greater than 8 or not? If it is greater, locus of P is ellipse. We learned it in the last lecture. So, it is going to be ellipse. Find the area of the path traced by them, okay. So, if this is 10, then that means 2A is going to be 10, which means A is equal to 5. Now, distance between these 2 points, the moment we get clarification that it is going to be ellipse, then distance between these two flag posts is going to be 2AE. So, here we got 2AE to be 8 units and 2A to be 10 units. So, we can directly get E from here, E becomes 4 by 5 by just taking the ratio. So, if A is 4 by 5, we can get B as B square equal to A square into 1 minus E square, which is 25 into 1 minus 9 by 25, which is same as 9. So, B is going to be 3. So, if A and B are known, we can find the area of the ellipse. What is the formula for area of ellipse? Pi AB. We learned this in differential calculus, which is the maxima minima. We generally learn this in integration, area under curve, okay. So, if you have not learned it, we are going to derive this in the chapter area under curve. So, basically area is going to be pi AB. So here we can just say that it is pi into 5 into 3, so which is 15 pi, okay. So this way we can calculate this question. This is, I think, very easy and also very interesting question, okay. So just quickly copy it. Okay, so next question. Distance of a point on the ellipse from its center is 2 units. Find the eccentric angle of the point P. So because in the question eccentric angle is mentioned, we have to attack the question from the eccentric angle point of view, that means using parametric form. But in general also, whenever any point's distance from center is given, then it is always better to start with the eccentric angle, okay. So let me just write the parametric form of this ellipse. So because here a square is 6, b square is 2 and a is bigger than b, okay, we can observe that. So point P can be written as root 6 into cos theta, root 2 into sin theta. And we have to solve for theta if the distance from center is 2 units and center of this ellipse is 0, 0. So we can directly apply the distance formula. So here it becomes 6 cos square theta plus 2 sin square theta is equal to 4. I have directly squared it because we know that the center is going to be 0, 0. So distance of x comma y from center is root of x square plus y square. So I have just squared it, okay. Now we know that cos square plus sin square theta is 1. So I will separate 2 cos square here and give it to sin square, it becomes 2 into 1, okay. So further we can write this as 4 cos square theta plus 2 equal to 4. Now if we simplify, we get cos square theta is equal to 4 minus 2 by 4, which is 2 by 4, which is 1 by 2, which becomes cos theta equal to, which makes cos theta equal to plus 1 by root 2 and minus 1 by root 2. Now what are the angles which are possible for this? To understand this, we have to also understand all possible angles of theta. What is the domain of theta? Theta can vary starting from this. If it is on the x-axis, it will be 0. It will vary from here to here. So it is covering basically all 360 degrees. But above 360 degrees, all of them are basically the repetition of the old angles. So we will take the theta as belonging to 0 to 2 pi. So at one point I am closing, so at 2 pi I do not have to close because they are the same angles. So that means here what are the possible angles? One angle is pi by 4, other angle is 3 pi by 4 and the next angle is 5 pi by 4, next angle is 7 pi by 4. These are the total 4 angles possible here. So even in general, if you look at these two, if you look at the ellipse, and let us say I draw any circle here, okay. So let us say I draw a circle like this, okay. So this circle is intersecting the ellipse at 4 points. There are 4 points here, okay. So imagine that I have drawn a circle of radius root 2 units, okay. So then that means radius 2 units. So that means I am actually getting 4 points of intersections. So the 4 solutions here correspond to 4 points of intersections, okay. So that way also you can justify, okay. But here the radius must be between B and A, okay. So if radius is too small, we may get a circle which is inside like this, which has no points of intersection. If radius is too high, we may get a circle like this, which also does not have any intersections, okay. Next, that is the idea here. Can we move on? Quickly make a note. Okay. Next, if the focus, center and eccentricity of the ellipse are respectively these, then find its equation. Okay. So, here I think this question also we tried to attempt in the last class, but now I will try to attempt this completely. Okay. So, first what is given here? Focus, center and eccentricity are given. So, let us plot them roughly. Okay. 3, 4 is a point somewhere here, 1, 2, 3, I am just scaling here. So, 3, 4 is a point here which is given as focus, and 2, 3 is the center. So, 2 units here and 3 units here, this is the center. Okay. So, here one focus is this side and center is this side. So, ellipse is going to be somewhat like this, and this is the center, this is one foci. Okay. So, now you remember the idea that I have given. We can directly get the equation of ellipse using these perpendicular lines. Okay. If you do it smartly, you can get this. Okay. Now, how do we do that further? So, let us get all the required conditions here. So, distance between these 2 points should be AE. Okay. So, what is the distance between these two? Let us take this center as, let us say, C and this as S dash. So, what is the center here? This is the center C, this is the S or S dash, it does not matter. Okay. So, CS dash is going to be root of 3 minus 2 whole square plus 4 minus 3 whole square, which is luckily going to be root 2. Okay, 1 square plus 1 square, it is 2, so root 2. This root 2 has to be 2AE. Now, what is E given as? E is given as 1 by 2. So, if we put E here, so we get A equal to root 2. We got 1 value A. Now, we will get B. Okay. So, what is the value of B? B square is going to be A square into 1 minus E square, which is going to be same as 2 into 1 minus 1 by 4. E square is basically 1 by 4. Okay, that is right. So, here we are going to get 3 by 2. B square is going to be 3 by 2. Now, this also means A square is going to be 2. So, we got A square and B square. Now, we just need these perpendicular lines. Okay. So, what is the equation of this line? We can get it by 2-point form. Okay. So, equation of major axis is going to be y minus 3 by x minus 2 is equal to, in fact, this is actually very simple equation. You see that when x is 3, y is 4, when x is 2, y is 3. So, y equal to x plus 1 is the equation. So, sometimes just by looking at the numbers we can get the equation. Okay. But here let me do it in a systematic way. So, this is equal to 4 minus 3 by 3 minus 2, which is going to be 1 unit. So, now simplify this, y minus 3 equal to x minus 2, and we are getting y equal to x plus 1. Okay. See, that is the same equation, especially when it comes to numbers, when points are given. And if I see any proportionality or addition of numbers, generally I spot them in the numbers only. Okay. So, you also try to make it a habit to crack such relations, because sometimes it makes you even happy also whenever you crack any relation. For example, whenever I crack any pattern, I feel immense pleasure or happiness inside. Okay. So, it happens. So, try to keep your gray cells working always. Okay. So, we got one equation of major axis. Now, we need equation of minor axis. So, here this equation can also be written like this, x minus y plus 1 equal to 0. Now, how to get the equation of minor axis? What is the best way? Swap the coefficients, put a plus in place of minus and then put the point. For example, here I am swapping coefficients. So, here there is 1, there is minus, there is 1 here, 1 and 1 got swapped. Okay. And in place of minus, I am just reversing the sign. So, plus sign and put the point. What is the center here? Center is 2, 3. So, x minus 2, y minus 3. Now, what is the equation? equation is x plus y minus phi equal to 0, that is the equation of minor axis. Okay. Now, let me put the entire data in a simple manner. Okay. So, we got one line, another line, both are perpendicular. This is the major axis. What is the equation? X minus y plus 1 equal to 0. What is the equation here? X plus y minus phi equal to 0. There is a point P here. Its distance from the major axis is always taken as d2 and its distance from minor axis is taken as d1. And what is the length of major axis? What is a square basically? A square is 2, b square is 3 by 2. So, what is the equation of the ellipse here? It is going to be d1 square by a square plus d2 square by p square is equal to 1. Okay. So, that means we can straight away put the formula for distance. Okay. So, what is the formula for distance from this line? It is x plus y minus phi by root 2 whole square by what is a square? Value of a square is 2, that we have just derived in the earlier page, and here this also this distance from the major axis. So, it is going to be x minus y plus 1 by root 2 whole square divided by what is the b square we derived? It was 3 by 2. You see it was 3 by 2. So, 3 by 2 here, this must be equal to 1, that is our equation of ellipse. Okay. So, we have just killed it with this step. So, what is it? X plus y minus phi whole square divided by what are we getting? 2 into 2 which is 4 plus x minus y plus 1 by 3 square by 3 equal to 1. So, this must be the equation of ellipse. We can also simplify it further and get the required equation in general equation form. Okay. That way we can get it, but this will give you complete picture of what is going on. Okay. Now, this is one idea of simplifying. Is there any other method of solving this question? Of course, there is one more method. I will give you that once after you note this. Okay. Come on, note it. Okay. So, what is the other method? So, take a snapshot of this page also. What is the other method? Other method should be like this. We already got C, we already got S dash. We can find another point which is S, which is the other focus, using the midpoint. Okay. So, let us say, so here we are actually not deriving any equations for major axis. This is based on the property that PA plus PB equal to 2A. So, let us just get that property. So, we do not need equations of major and minor axis using this method, we just need the foci. Okay. So, how do we get the other one? Because C is the center is the midpoint of S and S dash. If I take this point S as H comma K, so midpoint of S and S dash is going to be something like this: H plus 3 by 2, this is the x coordinate, K plus 4 by 2, this is the y coordinate. Okay. Now, this x coordinate must be equal to 2, that is the x coordinate of the center, and this must be equal to 3, that is the x coordinate, y coordinate of the center. Now, from here I can derive h. So, 4 minus 3, h is going to be 1, and here 2 into 3 6 minus 4, k is going to be 2. So, we got the other point. Now, what is the idea? Any point P here, if I take it as x comma y, So, this Ps plus Ps dash must be equal to 2a. What is a that we have derived here? It is root 2. So, 2a is going to be 2 root 2. So, let us apply the distance formula and get it. Okay. So, what are the foci here that we got? Both foci are 1, 2 and 3, 4. Okay. So, we have one variable point p here whose sum of distances must be equal to 2 root 2. So, let us just get it. So, what do we get here? Root of x minus 1 whole square plus y minus 2 whole square plus root of x minus 3 whole square plus y minus 4 whole square is equal to 2 root 2. Okay. Now, we want to simplify this and get a general equation. There are two square roots involved. So, whenever there are multiple square roots, do we blindly square it? Of course, to get rid of square root, squaring is the only method, but do we blindly square it or do we do any modifications? Of course, we do modifications because we do not want to handle complex simplifications. So, we take one term to the other side and then square it. Okay. So, that means here just check which is the easier form. This is going to be easier form. So, we do not take the second one, we take the first one to RHS because here simple numbers are involved. So, it looks like this: x minus 3 whole square plus y minus 4 whole square under root is equal to 2 root 2 minus root of x minus 1 whole square plus y minus 2 whole square, and then we square it. So, what do we get? Here we get x square plus y square minus 6x minus 8y plus 9 plus 20, 9 plus 16 is 25. So, here it is 8 x square plus y square minus 2x minus 4y plus 5. Now, it is not ended. There is one more extra term which is 2ab. So, 4 root 2 into root of again x minus 1 whole square plus y minus 2 whole square. Now, what is the advantage that we get when we take one square root to the other side? The advantage is these x square y square terms get cancelled, and whatever are the remaining terms, we keep all of them on one side and we keep the square root on one side and square it again and simplify. That way we can get the required answer, but this is going to be long. Okay. So, I personally do not prefer this method because it is algebraically long. Now, but the earlier method that we used where the perpendicular lines were there, that method is conceptually long. It takes lot of toll on your mind, but that method is faster. Okay. So, whichever you like you can use, but you should know both methods. Okay. Come on, take a quick note of this or a snapshot. Okay. So, now we will move on to the next problem. So, find the length of major, minor axis, eccentricity, coordinate of foci. So, basically we have done a similar question like this earlier. Okay. So, in the beginning of the lecture we have done a question like this, this one. So, I hope you like this solution. So, in the same way you try to solve this question. Okay. So, I am not solving this, I will move on. Okay. Next, a rod of length a plus b moves in such a way that both the extremities remain on coordinate axis. So, suppose let us say we have one coordinate system like this and there is a rod of length a plus b is moving on this so that both extremities lie on coordinate axis. So, these 2 points are not losing contact with the axis. Okay. Next, a point P divides the length in the ratio b is to a. So, there is one point here P which divides this in the ratio b is to a, and it is very friendly with the length also. Total length is a plus b and it is dividing with b is to a. So, this must be b, this must be a. Whenever we take this point of division, so what is the ratio b is to a? So, the first number you have to take it with the x side, okay, x axis side. The second number must be taken on the side of y axis. It is the standard convention. Okay. Now, we want to find the locus of P. So, to find the locus of P here, there could be many methods. I can in fact solve this question using at least 3 methods here, but I will give the fastest method for you. Okay. So, suppose let us say I take this angle as theta. Now, theta is not given in the question, I am introducing it, now it is my job to eliminate it. And if I take this point as let us say x comma y, this is my locus point, I am straight away hitting x comma y. Okay. Now, this perpendicular here will become y, this perpendicular onto y axis will become x. If this is theta, this is also theta. Okay. So, now in this smaller triangle, y and b can be connected using sin theta. So, we can say that y by b is going to be sin theta. And in this small triangle, x and a can be connected using theta. So, we can say that x by a is going to be cos theta. Now, if I take cos square theta plus sin square theta, it is naturally 1. So, that actually helps us in eliminating theta. So, here if I eliminate theta, so what do I get? X square by a square plus y square by b square equal to 1. So, this way I have found the locus to be ellipse. Okay. So, this is one simple idea of finding the locus. There is also other idea like you find the intercepts, write the equation of this line. You can take the rod as a line which is making intercepts, let us say x1 and x2 on x and y axis, alpha and beta or anything. Then use the use the Pythagoras theorem and somehow connect. So, you can do many such ideas, but this idea seems to be the fastest. Okay. So, quickly take a snapshot of this. Okay. So, can we move on to the next? So, here there is a circle of radius 3 units touches another circle of radius 5 units internally. Okay, so this looks like our question that we have solved in the last lecture. Okay, so these two circles are actually touching each other internally. There is another circle, so show that the locus of the center of the variable circle that touches the smaller circle externally and larger circle internally is an ellipse. So, we have to prove that the locus of the third circle which touches both these circles is going to be ellipse. We proved this in the last lecture that if we take the center, this center to be A, this center to be B, this center to be P, we can prove that PA plus PB is going to be a constant which will give us ellipse. So, this is an easier question. So, we will just move on. Okay, next. Okay, this is an interesting question. Find the center of the ellipse given in the second degree form. Now, what is the best way to solve this question? In general, suppose let us say this was any general equation. Okay, so we have one rough page. Yeah. So, let us say we take this general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This can represent pair of straight lines, circle or parabola or ellipse or hyperbola. Out of these, how many diagrams have a center? Circle has a center, ellipse has a center, and also our hyperbola has a center. Pair of straight lines is also having a center. In fact, the point of intersection of pair of straight lines is actually center of that curve. If we treat pair of straight lines as a curve, then point of intersection of these two straight lines become the center of that curve. Okay. So, here to get the center, what is the best idea? To go for partial derivatives. So, if I take this expression, if I take this entire expression as let us say capital F of x comma y, okay. So, this is my curve. So, or we can also take this as S, we know this standard notation is, okay. So, you can follow anything. So, dou S by dou x equal to 0 and dou S by dou y equal to 0. These two derivatives involving these two derivatives, okay. So, these two equations involving derivatives will give us two straight lines which are in linear form. Now, they may not be exactly the pair of straight lines that we are looking for, they are not, but solving those two will give us the center. This is the fastest and better way, okay. So basically partially differentiate this with respect to x. So what do we get? 2x here and here 2y, because derivative of x is 1 and derivative of this term is 0 because y is constant with respect to x. Now here derivative is going to be 2. For this and for this also derivatives are going to be zeros. This is one equation. Now again partially differentiate with respect to y. So what do we get? Here we get 0 and here we get 2x, here we get 8y, here we get 0, here we get minus 8 equal to 0. Now what are the equations? Just cancel out the common factors and try to simplify it. So here we get x plus y minus 1 equal to 0, here we are getting x plus 4y minus 4 equal to 0. Now subtract one from the other. So what do we get? 4y minus y is 3y and here minus 3. So we are getting y equal to 1. If I put y equal to 1, then x must be 0. So 0 comma 1 is the center of this conic, whatever it is. Because here it is already mentioned that it is ellipse. We don't have to check whether h square minus ab is less than 0 or not, but ideally we should. Okay. So these two conditions, delta not equal to 0, h square less than ab, these two conditions must be checked ideally for any general curve, but here in the question it is already mentioned that it is an ellipse, then it is not your job to check if it is an ellipse or not. We have to take it as ellipse and go for further proceeding. Okay. So this is the faster method to find the center of the ellipse. Okay. But learning shortcuts is not going to help us. We also have to learn better methods, which are the standard methods. Okay. So if you make a note of this, after this I will give you the standard method. Okay. So both these pages, try to make a note. Okay. So now I am going to give you the standard method. So let us take this equation once. Okay. So here equation is x square plus 2xy 4y square minus 2x minus 8y plus 3. 2xy 4y square minus 2x minus 8y plus 3. Okay. Wow. Okay. So we got the equation. Now in this equation, suppose if the center is h comma k, let us say our center is h comma k, let h comma k be center, then what we do is we shift the origin to the center. When we shift the origin to the center, now what happens when we shift origin to the center? In place of x, x minus h comes, in place of y, y minus k comes. Okay. That is if the curve is shifted, not if the center is shifted. If center is shifted, in place of x, x plus h comes, in place of y, y plus k comes. So here after we shift this, what is our new equation? It is going to be x plus h whole square plus 2 into x plus h into y plus k. Okay, so here I am going to quickly simplify this. So keep following me with this algebra. So y plus k plus 4 into y plus k whole square minus 2 into x plus h minus 8 into y plus k plus 3 equal to 0. Now let me simplify this further. So let me collect only the terms that are required. So first I will collect all second degree terms, then I will collect all linear terms, then I will collect all constant terms. So second degree terms are going to be the same terms, x square plus 2xy plus 4y square. You can blindly write it or you can also multiply and write it, it does not matter. Now let me take all terms of x. So from here I am going to get one 2ab term. Okay. So what is it going to be? 2hx, so 2h, and from here 2 into x into k, so that is plus 2k, and here there is no x term, here there is x term, so minus 2 plus y into. Now let me collect all terms of y. so here there is no y term, here there is y term, y into h into 2, so 2h. Here there will be y term 2ky into 4, so it is 8k, and here there is one y term which is 8 minus 8, and now the constant terms. Constant terms are going to be the substitution of point in this. So we'll just have to take these points. Okay, so there is square missing here. Okay, so h square plus 2hk plus 4k square minus 2h minus 8k plus 3. Okay. Now look at this. We have shifted the origin to the point of the center. So if the ellipse was somewhere here and the point was h comma k, we shifted this entirely somewhere here. So that means the x term and y term must be absent. Okay, so that means this complete coefficient of x must be 0, this complete coefficient of y must be 0. Okay. Because we shifted the origin to there, x and y terms must be absent, because in standard ellipse they are absent. So that means this 2h plus 2k minus 2 must be 0 and 2h plus 8k minus 8 must be 0. So these two conditions will give us the center. If I solve these two for h comma k, it will give me center. Now look at the earlier equations that we got. These two equations which are obtained by partial derivatives are basically these equations. Okay. So by shifting also we can understand this. Okay. So now you understood that in any equation of the ellipse, okay, in this standard form, okay, we missed that standard form. In the standard form, if x term and y term are absent, that means the center of the conic is origin, because now when we shifted, the origin becomes the center. It is the idea that connects both of them. Okay. So I think we will stop today's lecture at this point. I hope you liked our techniques today. We will meet again in the next lecture with more interesting ideas. Until then, have a great learning day. Learning shall never stop.